In part B, they give us g of x equals x to the fourth minus 8x cubed minus 5. And so let's again start with the first derivative. So we'll take the first derivative. G prime of x is equal to 4 times x cubed minus 3 times 8 is 24, x squared, and the derivative of negative 5 is 0. Now to find the critical values, we set the first derivative equal to 0, and we can factor out a 4x squared. That's going to leave an x minus 6 in parentheses. Now setting each of these equal to 0, we get our critical values. X equals 0 and x equals 6. Let's go ahead and take the second derivative. So g double prime of x is going to be equal to 3 times 4 is 12, x squared, minus 2 times 24 is 48x. And we will make a table with our critical values. So x equals c, and then we will find f of c, and then finally f double prime of c. We have two critical values, 0 and 6. F of 0, rather I should say g of 0. Let me fix that. So g of 0 is negative 5 if we substitute into our original function, and g of 6 is negative 437. And then I would plug my g double prime of x, 12x squared minus 48x, plug that into your graphing calculator and just substitute 0 and 6 and look at the signs of your answer. And so what we find is that we actually get 0 for x equals 0, and we get a positive value for x equals 6. Now, what does this mean for us? Well, conclusion. We have a local minimum at f of 6, g of 6 equals negative 437. How do we know that? Well, because g double prime is positive, and when g double prime is positive, that means that g is concave up, and if it's concave up, that means that this is a minimum. Now, what about 0? Well, unfortunately, we have no conclusion about x equals 0 because f double prime of 0 is equal to 0.